Okay, I'm gonna solve the problem 1113. They have several steps. I just label all the figure A. This is the strut, this is the tension, this is the weight of the strut, this is the weight of the central mass of the strut, and A over here is a hinge. So for part A, it says find the tension. And for find the tension, we know that the addition of all the torques and the hinge A it's equals to 0 because the system is in equilibrium. So we have tension, which is this, times the distance, which is L sine of 30, and its torque is in a positive direction, minus, because this other torque of the weight is in the negative direction, it's gonna be weight times L cosine of 30 minus this other torque for the central mass of the strut, which is equal to W L half cosine of 30. Altogether is equals to 0 because the system is in equilibrium. So solving for tension, we divided everything by L, both sides of the equation by L. So this is going to cancel out L's over here, and this is just going to be 0. So tension is equal to 3W cosine of 30 degrees over 2 sine of 30 degrees, which is equal to 2.6 W. This is part A. For part B, says find the magnitude of the force exerted by the strut. So we're talking about this force. So on its component, horizontal is f of x, and this one is f of y, and this is the direction theta. So for find the magnitude of this force, we need to know this and this. So we know that the system is in equilibrium, so we know that the addition of the force in y direction is going to be equal to 0, and there are just this component f of y minus this weight minus the other weight equals to 0, which is give you f of y equals to 2w. Then for find f of x, we know that addition of all the force on the x direction is equal to 0 as well, which is, this is going to be equal to f of x, which is this force, minus the tension equal to 0, which making f of x equals the tension, and this is equal to 2.6 W. That's the answer for the part B. And for the part C, it's asking about that direction, which is this theta angle. I'm sorry. For the part B, I forgot to find the magnitude of the force is equal to f of x squared plus f of y squared. Everything is square, and this is equal to 3.28 W. Now this is part B, sorry. Now for part C, we need to find the angle theta. And for find the angle theta, we know the tangent of theta is going to be the component of f of y over f of x, which is equal to 2w over 2.6 w. Canceling this out, we know that theta is equal to the arc tangent of 2 over 2.6, which is equal to 37.60 degrees, the direction of the force. Thank you. Okay, this is the second part of the problem 1113, as this is the figure V, which I draw the free body diagram. Note that the tension has its own horizontal and vertical components. So this is a 45-degree this time, not 30. What do we need to do? It's to find the tension. And for find the tension, we gotta to apply this addition of torques equals to 0. Why is equals to 0? Because the system is in equilibrium. So we gotta go torque, torque, and torque over here. So we gotta go work with all the torques on this that are generated on this hinge A. So we need that the first torque will be this, the tension in a positive direction, which is gonna be tension cosine of 30 degrees times the distance to the hinge A, which is L sine of 45 degrees. Then we have to go for the next torque. The next torque is this way, which is in a negative direction. So it will be minus T sine of 30 degrees times this distance L cosine of 45 degrees. Then we go for this torque as well. It's in the negative direction, so we go minus W, and the distance is half of this, so times L half cosine of 45 degrees, and all of this together is equal to 0. So what we can do over here is divide both sides of the equations by L and sine of 45. It could be by sine of cosine of 45 because they're equal. So we're gonna cancel out all the L's and the sine of 45 and the cosine of 45 as well. So we ended up with T cosine of 30 degrees minus sine of 30 degrees equals to 3W over 2, which gives you the tension equals to, let's put it at the end, equals to 4.10 W. That's the tension. That's part D. Then for part E, again, we need to find the magnitude of the force exerted by the straw, which is going to be, again, this is the force, component F, component Y, and direction. So we know, again, that the system is on equilibrium, so all the force on x direction are equal to 0, which is going to give you f of x minus t cosine of 30 degrees equal to 0, which is going to be giving you the end answer of 3.55 W, using this over here, of course. This is for the component of f of x, and for the component on y, same thing, all the force on y direction and equals to 0, and this is going to give you f of y minus the two weights minus the tension sine of 30 degrees equals to 0. And then using this and these values, we find that f of y is equal to 4.05 W. But we need to find the magnitude of the force, which is equal to square root of 3.55 W squared plus 4.05 W squared, square root of that, which is giving you a magnitude of 3.39 W. This is for part E. And the last part, for part D, we need to find the direction, which is theta, which is equal to the arc tangent of f of y over f of x, and this is equal to 48.8 degrees. And that's the last part of the problem. Thank you.